Hi everyone, this is the second video for amount of substance and it's on the ideal gas equation, which is part of Module 1 Foundation Chemistry for the AQA A-level specification. Hope everyone enjoys and thanks for watching again. Okay, so to start with a quick recap on stuff you should know from GCSE. About the volume occupied by a gas depends on a couple of things. First of all, the temperature, and basically the hotter the gas, the faster the particles are moving and the more space they will occupy. The pressure, and basically the pressure, the higher the pressure, the more compressed the gas will be and the less space it will occupy. Finally, the amount of gas, and the more gas particles there are, the more space they will occupy. Okay, so now we go on to what links these factors, and that's known as the ideal gas equation, and is represented by PV equals nRT, and you've got to know that for your exam, you need to remember it. And now we're just going to go through bit by bit which each one means. Okay, so starting with P. P stands for the pressure, and it's measured in pascals. It must be in pascals when you're doing the equation, but you could be given it in kilopascals, and to change it back to pascals, you just simply need to times by 1,000, and you must remember that. Moving on to V, which stands for volume, and this is measured in meters cubed. You could be given this in centimeters cubed, which is unusual, decimeters cubed, and you need to make sure you change it into meters cubed. So if you're going this way, you must divide by 1,000, divide by 1,000, and if you're going all the way, you divide by 1,000,000. And not that you need to know it for this one, but you might. If you're going the opposite way, it's times instead. The N's really simple, it just stands for the number of moles, and that's a common one that you often get asked to work out. It's really easy. R stands for the constant, and you're often given this in the exam, but it's also useful to remember. It's 8.31, and that's G mol per K. Moving on to the T, which stands for temperature, and this is measured in Kelvin, is what you need, but you might be given it in degrees Celsius, and to get to Kelvin you add 273. Again, that's a number worth remembering. Okay, so in the exam you're obviously going to have to rearrange the equation so that you can find out the answer to what you've been asked. So for example, if we wanted to find out the number of moles, the best way I look at it is to keep that on the side it's already on and move the other two. So if we move RT down to that, it'll be divided by, because it's times on that side. And obviously this is the sign switcher. Don't know how you've been taught it in maths, but that's the way I remember it. So if we were finding the number of moles, it'd simply be the pressure times by the volume divided by the constant times by the temperature. So if we do another, remember just always write the equation out first in the exam, how you remember it. And if we were, like let's say we're working out the volume, then we would just simply remember, keep that on the same side it's already on and move the pressure, because it's times on that side, it'll be divide on this side. So volume equals number of moles times by the constant times by the temperature divided by the pressure. Okay, so here's a little example of a question that you might get in the exam. This is quite a simple one, they do get more difficult, but if you just go through some past exam papers, there's quite a few of them. But anyways, have a go through this and I'll go through the answer in a minute. You could just pause the video. Okay, so first if we just write the normal equation out, PV equals nRT, then we need to rearrange it. So we're looking for the temperature, which is this one. So just move these two over to here. So temperature equals PV divided by nR. And then we just need to simply change them and fit them into the equation. So if we look, we need the P here, so pressure of 2000 kPa, and remember that it's in kPa and we need it to be in PA, so we times by 1000, so 200 times by 1000 is 200,000, and then we need to times that by the volume, so it gives us the volume here in decimeters cubed. Remember, we need that in meters cubed, so we divide by 1000 this time. So 1.2 divided by 1000 is 0.0012. And then we need to divide it by the number of moles given here, which is 0.5, times by the constant, which we know is 8.31. And if you work that out on the calculator, it will give you an answer of 57.76. Okay, so now we can tick off the ideal gas equation. Thanks again for watching. I hope you follow me on Twitter because I update loads on there. It's chem_AQA. Thanks for watching.